All right. Good afternoon, everybody. My name is Dr. WP Wahl. I'm the Director for Student Life at the University of the Free State. I'm also joined in this session by one of my colleagues, Teddy Sibiya. He's working in the what we call the COFSI ACT office, which is the office that deals with active civic teaching. And so we will present to you a program, a co-curricular program that we've initiated at the University of the Free State for the past 4 years. We really believe this program is aligned with the Fourth Industrial Revolution and the development of specific graduate attributes in that regard. So I would like to start this presentation by one of our recent videos that we have created about this program. So enjoy it.
Right, good morning to the national live streaming of the Eco Vehicle Race 2021, coming live for you from the University of the Free State. We are running electric vehicles here, powered up by solar charging stations. The idea of this entire race and skills program that we are offering is sustainable energy and powered by COFSI X and proudly sponsored by Mesita. Cars are ready on the startup grid. We are ready. 5, 4, 3, 2, 1. And the laps are adding up. Remember, the goal of this endurance race is to see which group can cover the most laps in the assigned allotted 30 minutes with your battery still having energy in it. And the winner of the pit stop this year, 2021, is team number 4, Vivimar. For the next cup, we have Smart Lap Race, and that is team number 1, Sonletel. Then for our main race, team number 7 by the team Soet by Resta. And now for the big one. There is a team that's going to lift that cup today as the overall winner of Eco Vehicle Sustainable Energy Race 2021. Sonletel, team number 1, overall winner.
Okay, so there you have it. I just wanted to give you a taste of what our program is all about. So we're going to talk about the Eco Vehicle project at the University of the Free State. And in this regard, we will focus firstly on why is this project important to the University of the Free State? What is the Eco Vehicle Sustainable Resource Project all about? Thirdly, how does the project work? So in the third movement of this conversation, we will go into the nuts and bolts, so to speak, of this project. And then we will end off with some pedagogical considerations. Right, so why did we create the eco-vehicle project at the University of the Free State? So there's a history to it. We, as many of you might know, we also had the old float building at the University of the Free State for many, many decades, and that served our student population very well. But in 2015, 2016, we realized that this is a bit outdated. We need to reconfigure this program and this project. And the question was really, what could we do and what could we create that would be more aligned with the current student generation, that would resonate more with the current student generation, and that would also develop them for the future world of work. And that was an important question for us, because we understand that a degree certificate in and of itself is not sufficient anymore to assist students to find work in the future world of work and in new and emerging business models. So in the university and in higher education, we started the conversation really about graduate attributes or learning and developmental outcomes. And what we do is really to position each and every experience from different angles of the student experience in such a way that it develops certain attributes, so that when students leave and they go into the job market, that they're not only leaving with a degree certificate, but that they're also leaving with an array of attributes, what we call graduate attributes. And we felt that in this process of reconfiguring the old RAG portfolio, the old float building project, that we must look specifically and intently about the development of attributes that would be more aligned with the fourth industrial revolution. Attributes like technological skills, robotics, critical thinking, reflective thinking, problem solving, collaborative learning, and so on and so forth. In that time, while we were busy with this process, I read an article, or I watched an online video. I can't remember what the source of the information was, but it was about a couple of students in the United States, at the university in the United States, that were working collaboratively with Elon Musk at SpaceX on one of these projects that they are developing to go to Mars. And when I read that, I really became upset about the information, because I understood that in a couple of years from now, our students will compete against those students in a global market, labor market, and also business market. Yet, those students get the opportunity to develop certain skills and certain attributes that our students are not exposed to currently. And that really brought about the birth of the eco-vehicle sustainable resources project. So the next movement in the conversation, we will focus on what is the eco-vehicle project. But before that, I want to show you another video that will open up to you a little bit more the notion of graduate attributes and what we aimed at developing within our students. So, so I'm going to show you this video with the intention that it will illustrate to you the heart behind developing attributes within our student population. Enjoy that.
Our world is changing. Our future is changing.
And there's never been a better time
to be involved with this.
The thing that got me interested in the eco-vehicle project, isn't it obvious? This amazing idea that you build your own car and then race it. I mean, what's cooler than that? It's a concept that has really grabbed the interest of young people all around the globe. Our generation is learning to look at things differently. One of the things I value most about the project is that it's really taking us one step closer to saving the planet. Our generation is learning to do things differently.
One more thing about our generation, we're not quitters. Even though the challenges are very real.
Global warming, the energy crisis,
growing unemployment. The mere fact that you are part of the eco-vehicle project means that you have chosen to be part of the solution.
We are 3 months into 2021, so by now you should have completed cycle 1 and cycle 2. This is your mini solar charging station, your gear car, and your Bluetooth car.
For me, the building of the small cars was so much fun. It's certainly not only boys that like playing with cars. The cool thing is, we are harnessing new technology for old needs. And knowing we're doing this with zero fossil fuels and zero impact on the environment is super exciting.
Soon we'll be moving on to the next stage, the real deal, where the actual race cars are going to start taking shape.
But of course, the highlights of our project still lies ahead, and that is
Racing Day! They say the vibe on Racing Day is just incredible. I can't wait. The 15th of May, when all 10 teams get the chance to see who's the best of the best.
But it's much more than just fun. So what's in it for you?
By being part of this project, you're developing a critical skill set that will be vital for the future.
So your certificate could be a passport to the new world of work. Let us help you get there.
This is also a project that Kofsi Act is very passionate about.
Remember, none of us are doing this alone. It's all about the team. Draw on the strong points of your fellow team members. Use your team WhatsApp group. If you don't have one, get one. Not the time to procrastinate.
Or to hesitate.
Or even to re-evaluate.
This is the time to initiate.
Right, so that was just a way of illustrating aim of developing certain graduate attributes in our students that are participating. So what is the eco-vehicle project all about? So when we started this project, we created a vision for ourselves. And in that, we indicated the timelines got adjusted a little bit, but in essence, it boils down to we saw electric vehicles with solar charging stations built by different student teams, each team applying integrated skills and knowledge in 5 engineering fields, developed through 5 skills programs between July 2020 and May 2021, competing in a sustainable energy race event on 15 May 2021 to establish a blueprint that can be duplicated in secondary schools and other universities and colleges. So that's really what we envisioned in a nutshell. And I would just like to pause by each one of these aspects that we envisioned to give you a good grasp of what the project is all about. So first of all, the eco-vehicle project is all about electric vehicles with solar charging stations. And this is really internationally aligned. They call it the the F24 race category. You can go and Google it, but it's really well known around the world where young people, not only young people, but teams, raced against one another with electric vehicles. And we want to create something like that at the university. So, so we developed our own prototype in that regard. So the vehicle that you see there is something that our instrumentation and engineers that worked on the project developed themselves, as well as the solar charging station that actually charges the battery that goes into the eco vehicles. So, so all of that, both the charging station and the vehicle were developed by our instrumentation and engineering team. It's also secondly, the project is also secondly about building that these vehicles and charging stations must be built by different student teams. And in this year's race, in May, we had 10 teams from the University of the Free State that participated in this event. And this was intentional because we believe that learning is a social construct. We believe that students learn from one another. And that's the best, one of the best ways that young people learn. But also project-based learning is a big thing. So we envisaged from the beginning that different student teams from our different student communities will come together to build these vehicles and solar charging stations. The third aspect of the program focus on that each team must apply integrated skills and knowledge in 5 engineering-related fields. And the fields that, that we combined in this project is mechanical engineering, structural engineering, green energy, sustainability, and software engineering. So all of those 5 fields were incorporated in the project and is developed in various ways in the project. The next aspect of what the Eco Vehicle project is all about, it's about skills programs. So we developed the knowledge, the engineering knowledge, 5 skills programs between July 2020 and May 2021. We've developed these skills programs with a team of engineers and a structural design experts to combine these skills programs. The skills programs are fully online, but it articulates towards the practical application of the knowledge in building different products. So you will see that the trajectory here starts at the bottom with a small gear car and solar charging station. So there are 5 cycles. The end product of cycle 1 is a small gear car and a small solar charging station. In other words, as students go through the learning material and the exercises embedded in cycle 1, they are practically building a small gear car and a small solar charging station in order to develop at a very basic level the necessary knowledge and skills needed to go further. Then in the cycle 2, you'll see that that's illustrated by the next block. They build a small Bluetooth car. So you'll see that the knowledge and skills are layered one upon the other, and it becomes more complex. So in cycle 2, students, as they go through the material and as they build the kit that has been given to them, they build a small Bluetooth car, and they actually program the chip on the car with their cell phone, and they steer the car from their cell phone. In the next cycle, cycle 3, the aim of cycle 3 is to build the big eco vehicle and to assemble it with the necessary knowledge. Cycle 4 is all about building the big solar charging station. And then cycle 5, of course, is all about energy measurement and conservation during the race day. So it's about strategy during the race day. So all of this culminates into the race day. So that brings us then to the next aspect of what the project is all about. It is really about taking all of this, the teams and the skills development, and what they built, and then allow students and young people to compete against one another in a sustainable energy race event. And of course, we had that event on the 15th of May. That is what the video was all about that we started with. And then lastly, what this project is all about, we envisaged from the beginning that we wanted to create a blueprint that could be duplicated in other secondary schools and other universities and colleges. So that is the dream, that we're not only impacting the futures of our students at the University of the Free State, but that we enable young people across South Africa to develop the necessary skills and knowledge that would position them more optimally for the future world of work and emerging business markets. So in that regard, before we go on to the nuts and the bolts of how the program works, I would like to show you a third video. So just hang on.
So basically, the scale model is like a smaller version of what the final project is going to be.
Luckily, your turning radius is great.
It's not that much now. So today I'm going to get a chance to test drive the actual model that is going to be, we're going to use to race for next year.
The eco-vehicle project is all about electrical vehicles with solar charging stations. A very specific skills development program has been designed to take students through 5 practical cycles, starting by a little scale model of an electric vehicle. They actually build the real model with which they will then compete in a race. The value for the students of the program is exposure to the global market of sustainable energy, and for them then to develop specific skills that will position them very favorably in the future world of work.
I was the first person to actually test drive it, so it was a very amazing experience. This project has definitely taught me that green energy is the way to win. I definitely feel like it will be the cornerstone of my career in the future.
All right, so now we would like to go into the nuts and bolts of how the program works. And maybe just a side comment from my side, you will see that we continuously refer to Mediated. So in the process, while we developed this project, we realized that in order to do it at the level of excellence where we wanted to pitch, we need some external funding. And we then subsequently submitted a project proposal to Mediated, and we were successful in that regard, and that enabled us really to develop the program at the level where we want it to be developed. Can I ask the help desk at this stage just to call Teddy also to the stage, please, while I explain the next slide. So the next slide is, I would like to start just to explain how does the teamwork and sort of the human side of the project work. And after I've explained this slide, I'm going to give over to Ted to explain further what they did with the project. So so you will see that on the periphery there are 10 small circles, one yellow one and 9 blue ones. Each one of those circles is written car and charging station. So each one of those circles represent a student team, and a student team is made up out of 18 students represented in the block on the top right corner of your screen. So from each residence community, we selected 5 students plus a team lead or a coordinator of that residence, and collectively those 3 residences in a team of 18, and each team leader. So you will see that we then made up 10 different teams. The reason why one of the circles is yellow is because that is our computer students that we also allowed to participate. Then just in that circle, just inwards, see that there are green, and that actually a so engineering senior undergraduate engineering students that we train to be tutors in the project. So as the different teams went through the skills cycles and started to build first the small scale models, and then started to involve the larger models. These engineering mediators provided guidance, mentorship, tutorship about some technical things. And that was quite important because some of these students, we deliberately allowed any student to involve in the program. They can study education or this. Other students that know nothing about electronics and robotics and really take them from the ground and build them up. And for that, we use the engineering students that will see the Tesla, build that, the orange block, and it says go coordinator. Really, our project go coordinator, it is a required engineer and knowledge was also video. Parallel to that, on the left-hand side of your screen, you see that it says Kursi Act Team. So Kursi Act is an office, stands for Active City Teaching. It's an office with student affairs at the University of the Free State that assists continuously with the whole project, encouraging students, meeting with students, making sure that the whole project runs smoothly. Of the ACT side to let this program run smoothly. And I'm intentional with this because I want you to understand and get a taste of what it means to deliver a program like this. Thank you, Teddy. Over to you.
Okay, thank you, Dr. Wahl. I'd like to take this opportunity to greet everyone and thank you for joining us today. I am Teddy. I am a representative of the Kursi Act office. I was totally cut off there for a few seconds, so I might repeat some of what Dr. Wahl has mentioned today here. So we are basically, from our office side, working very closely with what Dr. Wahl has explained now as the team leaders. Now, the team leaders are obviously representative of the different residences that are on campus. So through our office, we're able to sort of train the team leaders, motivate the team leaders, and they are then doing that same motivation and supporting the rest of their teams. So how we've been doing this is obviously it's been quite a challenge, especially as feedback from the team leaders, seeing that most of this has shifted to an online sort of interaction because of COVID-19. So the challenges then raised from there because they can't really interact properly or communicate as they would have otherwise if it wasn't for COVID-19. So we, through continuous engagement, try to always motivate them so that the project was obviously a success as it was at the end. We did this firstly last year by introducing sort of a competition amongst the teams where they will get an opportunity to quickly go through the material. We want to support them to move through the material that is required of them, and then so that they can have a product or an end product where they will be able to win a competition by going through the steps as they were. So this made a lot of them start being very interested in the program, as they initially were when the thing started, when the program started. So this competition was of simple things. As you will find out later in our presentation here today, with the different steps and the cycles that they had to build. So from each cycle, we had a little thing that they had to do there, and then moving on to the next cycle, a few criteria that they had to meet so that to have a full picture at the end. So to support the students now through this whole online thing, we opted for bi-weekly meetings. Now, during these meetings that we held with them, we were able to sort of get feedback as how far they are with their projects and any questions and that they might have, or rising problems that they might have, information that they've collected from their teams about different challenges that they might have. So through our bi-weekly meetings, we were able to assist where we can at that moment, and then obviously they would refer back to their teams and sort any challenges out. And then since this was happening online, we had it in 2 different slots so that they can all get attention more likely, so if the groups are smaller. So then their challenges would then be solved at that point, and then also the building coordinator would also have a short sort of session with them where he motivated them to continue to go through. So the office, we handled all those particular things. And then in the beginning or the early stages of this year, when at that moment in the cycles, they have completed both their charging station, their gear cars, and their Bluetooth cars, they would then all meet together where we held a team building session, so to put it, where the students would get an opportunity to meet each other for the first time, since it's been a challenge that they've been doing this online. So they meet each other for the first time, they meet their different teams, and they meet their bigger groups. They got an opportunity to meet their engineering mediators, which closely assisted them with the project. So in this session that we had, we had a lot of basically activities and exercises where the students would then be encouraged to work in teams. They would be encouraged to go through critical thinking, collaboration, and so forth. So the students then got this opportunity to be directly involved now with the 2 cycles of the building the models of the cars. At that point, a lot of them obviously had problems, especially with coding. And since we also invited the engineering mediators who help a lot throughout the project, they were able to be assisted, especially with the parts of coding, where they had to code their Bluetooth cars and link them via their devices so that they are able to control that session. And then at the end, during that day, to also just sort of build their spirits for the bigger part of the race, they had a mini race. So we put it where their cars. If I am able to share here, I think I am able to. I would like to quickly show you how this race, this mini Bluetooth car race was. I'm quickly just gonna press share here. Okay. So I made the video move quite fast throughout, so that it's just to show basically how it was. So we created small obstacles on the floor, and then after sitting for a few hours trying to get the Bluetooth cars ready and trying to go through all the coding that has still been missing, or if there were any other glitches, the engineering mediators were available there to help them through all that. And then they worked inside their groups to share information, switch cars around, see which they had different problems at the time, so they would help each other. When one is well versed in one, then they would help each other and so forth. So they got motivation not just from the engineering mediators and ourselves, but also through each other. And hence they had this. Then at the end of the day, they put their cars outside to charge for a few minutes through the solar panels that they had there. And then after that, they were given an opportunity to race the eco vehicles, also the Bluetooth vehicles throughout the small course that we've created for them. And then what we also then do, this was now closer to the race and closer to the big day that we've all been anticipating. We had a lot of different workshops. This was now when the vehicles were built by the instrumentation division of the UFS. So the students then got very excited again because the cars were now ready, and theirs was to test the vehicles and have a feel for the first time of how that was. So through our office, we facilitated for that to happen. We'd communicate with the engineering mediators as well as the team leaders. The team leaders would then communicate with their teams to have a meeting at a particular time on campus where they would have a free road where they would be able to race their cars and record how much energy it uses, all in preparation for the race that they were heading towards. So we then helped them with all of that, and they needed a lot of other things that were to help them. So they needed to understand some of the things that have been learning throughout the cycles of the building of the smaller cars were now put into a more practical sense, where they would see the smaller motor, and now it's in a bigger sense, the smaller batteries, and now in a bigger batteries, and how much energy it consumes in a different time slot over different slopes. Through these facilitated workshops, they were even able to understand simple things as the structure of the car, where they understand, okay, this is a car, for example, it has a very flat nose to the front, and then the engineering mediators through these would explain why they've created certain things in the vehicle, for example, the nose for aerodynamics and so on and forth like that. They were then, through those test driving of the vehicles, decided which person is better suited to drive the eco-vehicle to save the most energy and so forth. So all these were then facilitated through the COFSI Act office. Thank you, Dr. Wahl.
Study is really, one of the center pins in the COFSI Act office, and really played a huge part with the rest of the COFSI Act team to make this possible. So they worked very in a hands-on way with this project. So I just want to share with you a video that the COFSI Act office created in all of this, just to help them motivate the students and engage with the students. Sense of what they had to do in all of this. Okay, so there you have it. I think they've been very creative in what they did. So what I'm going to do now is I'm going to take you step by step through the different cycles. The actual material that we use to train the students. So you will see that just again, there are 5 cycles, and each one of these cycles end with a product, a physical product that the teams or the individuals had to build. And the material that we created is of such that it actually takes the students step by step to build the necessary knowledge and skills to be able to build this product. So again, the end of product cycle 1 is a small gear car and a small solar charging station. The end product of cycle 2 is a small Bluetooth car programmed on a cell phone. The end of the 3rd cycle is the big eco vehicle. The end of the 4th cycle is the big solar charging station. And then the end of cycle 5 is the race day, where they focus on energy measurement and conservation. Predominantly, the first 2 cycles are individually focused. So individuals received kits with these components, and as they work through the material, they could engage with the COFSI Act office in the engineering mediators. But it was largely, these 2 cycles were largely individually focused. But from cycle 3 up to 5, the focus shifts much more on the group in terms of workshops together and so on and so forth. Of course, it's not clear-cut, as I explain here, but that is just the overarching focus of these different areas. So let's start then with cycle 1. The focus of cycle 1 is, as I indicated, to build a small charging station and a small gear car. So we've actually asked the students to create videos of their end products. And I want to show you 2 videos that we've received from students, a student specifically in this regard, about the small charging station. And then afterwards, I'll show you a video on the small gear car. And when I'm done with that, we will go literally to the learning management system of the university, and I want to show you the material that we use to develop Cycle 1 and Cycle 1A and Cycle 1B. But this is just to give you a sense of what the end product is all about.
In this video, we will test whether the propeller is rotating on the proper circuit, whether the buzzer is connected to the proper circuit, as well as the two LEDs. You see, if you connect the paper clip to the first magnet, the propeller will turn on. Let's test it. Now let's test the LEDs. If you connect the paper clip to the second magnet, both LEDs will turn on. Now let us look at the last test for this video, the buzzer. If you connect the paper clip to the last magnet, the buzzer will turn on.
Okay, so that was then the end product of Cycle 1A, and then the end product of Cycle 1B. I'm going to show you that would be the small gear car. So a video that the student that built this created, and so each and every student that participated in this program had to build it.
In this video, we will test whether my gear core corresponds with the on and off switch and whether my gear core is able to move. First, let's test the switch. Now let us test whether my gear core moves.
Okay, so what I want to show you now is I want to go to the learning management system of the university, and I want to illustrate to you how the actual learning material looks like that the students had to work through. So I am now currently on the learning management system of the university. It's called Blackboard, the Blackboard Learning Management System. You'll see that there's an introductory page to the eco-vehicle project, just a welcoming message, introduction. There's Anton Karlitz, the coordinating engineer, just giving a background of who he is. You'll see that here are the engineering mediators, the allocation of the different teams to the different engineering mediators. You'll see on there. Explanation of why are we doing this, the program outline of Cycle 1A, 1B, 2, 3, 4, 5, what will be required of them, and then the workshop information. We've also created certain workshops, although the rollout of this was highly impacted by COVID. So of course, as I then go to Cycle 1A, it takes you then to this cycle, and then project 1 is how to build your own mini solar charging station. So as we then go into the course, and this is really the nuts and bolts of what this is all about, they will actually then go to the course on how to build the solar charging stations. So there's just the introduction, and this is the outline of the course. It starts lesson 1 with circuits, lesson 2 on assemble your mini charging station frame, and of course in this we build in principles of structural engineering as well. So you'll see now how these 5 different engineering fields are coming together in the learning cycles. Lesson 3 is all about resistors. Lesson 4 about switches and control. Lesson 5 about solar and energy movement. Right, so let's go to the introduction. This is just the introduction to how to work with the material, and as they continue, they will get a project overview of the different, and as they click on that, it will explain to them you know, what the purpose of each lesson is, just very briefly, just to give them an overview. And then we'll give them just how it should look like, what they should build. I'm just going to run through this very quickly, just a graphic illustration of how the end product should look like right at the beginning. And then what components they would have in the kit that they have received to build. So now they will then move to lesson 1. The activities would be to set up the control board, to add a battery to the control board, to create a circuit, to use a multimeter to create the volts created by your battery circuit, to create a light bulb circuit, connect your lights in series and see what happens, connect your lights in parallel and see what happens, and create series and parallel circuits on your control board. So those would be the action steps they would typically go through. There's the introduction. We also try to bridge it to real life situations. And then we start with activity 1, set up the control board. So of course there are very clear illustrations of what they should do with these activity steps, step 1, step 2, step 3, step 4, step 5. And then, and now we start with the batteries, you know, just information about AA batteries. And so you can see we try to interweave practical activities with theoretical knowledge as they literally build the small solar charging station. Then activity 2 would be to add the battery, again step 1, step 2, and step 3, what to do. Information about multimeters, what is a multimeter, you know, voltage, current, resistance, the basic multimeter, positions on the multimeter, the DC volts and AC volts, explanation of Ohm's law, and then it goes to activity 3 to measure the voltage, step 1, step 2, step 3. And you can see that we've really tried to scaffold the information and the activities very at a very basic level. Here they are, you know, taking the steps to create a simple light bulb circle. Activity 5 is to connect the lights in series, step 1, step 2. Okay. Activity 6, connect the lights in parallel, step 1, step 2, step 3. And then as they go through this and they struggle, they can then contact the engineering mediator or the Corsair Act team to actually find more information. Right. At the end of each lesson, there's also a knowledge check that they have to, you know, just with multiple choice questions. And then they have to tick then the milestones that they have then completed in lesson 1. Right. So we're still busy with with cycle 1A, building of the mini solar charging station. Then they will go to lesson 2. Just give them the activities, 5 activities: assemble your station, assemble the pillars and support, install electrical components, do the wiring and fit the control board, connect the control board. So again, there's an introduction, a sneak peek of how it should look like. And then activity 1, we start with assemble the roof. So, you know, then they would typically go through step 1 and step 2. Activity 2 would be add the pillars and structural support. So in here, you will see that we've added the principles of structural engineering at a very, very basic level to teach students what it takes to actually assemble a very good structure, right? Information on trusses and support. And so then we bring in information, you know, how it should look like, also with roofs, and we try to bridge it to everyday life. Activity 3, install the electrical components. That would then step 1, step 2, step 3, 4, and 5. Activity 4 would be wire and fit the control board. Again, we take them through the steps and explanations how to do that. Connect the control board. Again, 5 steps. I'm not going to go into detail, but this is just to give you an indication of the steps they have to go through. And then the milestones again, they have to check, I assembled my station, I assembled the pillars and support, I installed the electrical components, I did the wiring for the control board and fit it into my structure, I connected the control board. Right, so that's the end of lesson 2. Lesson 3 is all about resistors. Measure resistance, test different types of resistors, add resistors in series and parallel, do a multimeter resistance test, test the speed of the motor, control and change the speed of the motor. Right, so here we provide information. Why do we need resistance? Introduction to resistors, the resistors table we provide to them. We nudge them to cry, and then the resistors and cranes. How does it work with cranes? Now we start with the activities. You know, just measure the resistance, again, the steps to do that with the explanation. And as they practically go through these things, they learn the necessary skills and knowledge. Activity 2 is test the different resistors, what they need to do step by step to do it. So it's very basic and very simple, but as they do it and as they assemble their own kits, they are then learning. Activity 3, add resistors in series and parallel, what they need to do. Then how to do a multimeter resistance test, the action steps to do that. And activity 5, test the speed of the motor. And you would have remembered in that video, the paperclip, what they then used. Activity 6 is all about the control and change of the speed of the motor, how to do that, steps, path of the least resistance, short circuits, information about short circuits, and wires and cables. And then there's a knowledge check that they should complete. And then also the milestone check. Right, then they go to switches and controls. We're still just busy building the small charging station, but you can see it's layered in such a way that it's very practical, and it is layered, you know, that we build slowly but surely the complexity of what students need to learn. All right, so step 1 is add a push button. Activity 2, control a cooling fan. I'm not going to go through all the steps, but you get the idea. Activity 3 is add a slide switch in series. Then we bridge it towards a hedge cutter, knowledge check. and then of course the milestone check at the end. And then they go to the last lesson, the solar and energy movement, introduction, information on energy, energy sources. So there we start to touch on renewable energy and non-renewable energy. So we start to introduce green energy to them. What is solar energy? We started to explain that. About inverters, the off-grid system versus the grid-tied system. So we explained that. So we tie this really to green energy, and then solar panel ratings. Right, so information on energy calculations, the triangle. You know, power is measured in watts, current is measured in ampere or amps, and voltage is measured in volts. And then an example of that calculation. So we start to learn them how to calculate energy, and then daylight hour calculation, information about batteries, rating of batteries, how does a charger work of a battery, and to make it real. Okay, so here we've got activity 1. So they've got literally a small solar panel now that they must connect to the small charging station. All right, again, steps 1, step 2, 3, and 4. Test that the circuit is working. 3 steps. Activity 3, test how much power the charger station uses. All right, 7 steps. So now they again use the multimeter, and then a knowledge check and a milestone check. And as they finish then lesson 5, they have completely built their mini solar charging station, but they have gained already a lot of knowledge and skills in terms of solar energy. So then we go back to the Blackboard. At this stage, I would like to ask Teddy just to provide some feedback. You know, how did he practically experience, and how did the students practically to build the mini solar charging station? Teddy, over to you.
Thank you, Dr. Wahl. Yes, this was actually quite an experience, especially because in the previous years when we started the project, the cars were already built for us, and all we needed to do was drive them. But in this case now, when we were directly involved in understanding the small components of the car and how it's actually started, was very, very interesting. And a lot of people were so excited, especially when we were going through this. You already have an imagination of how you want how the end product will be. So you're going through the material at that time, trying to get to the point where you were able actually to use your own the mini the solar panel to actually charge a car and see that working out. So you'd find a lot of students actually learned a lot of things, especially because the material always relates to something that you've either seen before or read about earlier in the internet or wherever, because we all know about, for example, the Teslas, those electric vehicles. And now through this, we understand how they actually use all those lithium batteries to run that bigger car, and how you're going to be directly involved in learning that. So it was very interesting. There's a lot of things that we didn't know, for example, how they work when we received it in the kit. For example, the multimeter, when you look at it, it has a lot of things on it, but through going through the material, you understand why there's different things on it, and then learning how to test with your own multimeter the different voltages and currents of the things we're watching. So it was really interesting. Overall, it was interesting. What I personally found very interesting was especially with the solar panels. Learning that solar panel is charging at an optimum when it's facing a certain direction to the sun. I mean, we've seen solar panels and how they've always been on roofs, but to understand how the sun passes and how that actually creates the energy that ends up charging a battery was very interesting. So that was the first experience when we first did the course. I mean, everyone was from different faculties, everyone was doing studies, and all this seemed as if it's something that needs to be done by an engineering student, but the material really helped us understand that going through the phases one by one, it was quite simple and very fun indeed. Thank you.
So, right, so as we go on, of course, the focus of cycle 1B is to then build a small gear car. So again, as we go to the material, it follows the same principle. I'm not going to go into that much detail, but the overview of this, of project 2B, to build a small gear car, is lesson 1 is all about an electronic breadboard. Lesson 2, magnets and motors, sensors and components. Lesson 3, lesson 4, introduction to transistors, and lesson 5, transistors and sensors. Right, so as we begin the course, you know, it gives an overview, and then as they go through the project overview, we give them, first of all, again, a very clear picture of how the gear car should look like. At the end, what they need to build, and then what the components would be in their kit. We then also provide a video to them. I'm not going to play it now, illustrating just the gear car components. And so then they start with lesson 1 about the electronic breadboard, so to speak. Again, we've introduced some videos, short video clips, and then again activities. What they need to do, go through the activities. Activity 2, again, different steps, a video guide that we provide in this case. Maybe I can just play, see if it plays.
Now, in chapter 1, we're going to look at our electronic breadboard. That is this little breadboard right here. Now, if you've done the basic electronics course, you'll remember that we used a snack board, which was a lot bigger. It looked something like this. We used this snack board. Now, this snack board had...
Okay, so I'm not going to go into detail. And then again, it ends off with a knowledge check and some milestones that they have to tick. Then they go to lesson 2, magnets and motors. Again, information about magnets, information about how does magnets work, and opposites attract. And so electromagnets, what are that? And then activities. As they go through the different activities, of course, they learn again all about magnets and motors. How does it work, right? And slowly but surely, we're starting to build the necessary knowledge and skills all about magnets and motors, right? How does it work? So it's no use for them to make it part of the gear car if they don't understand it. Then sensors and components, different aspects of sensors. Activity 1 is all about the multimeter to measure the resistance of the LDR. Not going to go through all the activities. It ends off again with a knowledge check and milestones. Then lesson 4 is all about the introduction to transistors. All right, everything about transistors that they need to know. And as they do this, they go through the activities, they assemble their kits step by step, and we do a knowledge check and a milestone check at the end. And the same with lesson 5, transistors and sensors. Then combined, activities that they have to complete. We bridge it to a safe, and actually then how circuits are used literally in cars. Knowledge check, and we do the bridge. Okay, so that's the gear car, the building of the gear car. Of course, cycle 3 is the Bluetooth car, and maybe at this stage I would just like to again show a video of the Bluetooth car that the student built, just to give you a sense of what the students then did.
In our last video for this project, and for me personally, the most fun part, we will test our Bluetooth car. The Bluetooth car is so cool that when you change gears, the color changes from a dark red to a brighter red. When pressing the up arrow, our Bluetooth car will move forward and the front lights will switch on. Let's hit reverse. When pressing the down button, the car will go backwards and the rear lights will switch on. Now let's test left and right. Pressing the arrow which indicates left or right enables the car to turn properly. Now the buzzer, better called the Bluetooth car's special router. The Bluetooth car's buzzer does not only have one sound. Let us listen to the different sounds and also take a careful look at what the lights does.
Okay, now that is students for you. They will always bring in something interesting at the end. So, yeah, so just very quickly, maybe cycle 2, to show you how the learning material looks like in terms of cycle 2. So we start, you'll see the cycles with always just energy consumption, sustainability, and so on, where we are now at in terms of the world, some statistics. So before they start to do this. Okay, so you'll see that the reflection on activity 2 before the workshop, coding and basics on coding and building the mobile app. Then there's information about the workshop, the material that would be required, workshop 2 for the mediators. Try now to bring in workshops as well together with the learning material, right? So, so this gives you a sense of the material used for the Bluetooth car. I'm not going to go into detail. Of course, I just want to also point out at the end of every cycle, we've also got a feedback survey that students need to complete. Right, then, okay. Then cycle 4 is all about then, that was cycle 2. Cycle 3 is all about the car, the assembly of the car, the bigger car. I have to say cycle 3 and cycle 4, we really struggled rolling out with the COVID. Actually entails getting students together. We've tried to do that, but in future years, it will be much easier to do that. But cycle 3 is all about assembling the bigger car, and then cycle 4 assembling the bigger solar charging station. So again, the same principles, just on a bigger scale. And then cycle 5 is all about energy conservation, measuring energy, and how to apply that in the race day. All right. And so it's just to give you a sense of the learning material in terms of cycle 3, 4, and 5. Okay, at this stage, I'm going to give over to Teddy again to explain to us just very briefly maybe his experience and the students' experience of assembling the Bluetooth car. That was a bit more tricky. And then I want him to explain what it took very practically from his team to organize the race day. And I'm deliberate in doing this because I want you to understand very practically what it takes to implement a program like this. So I try to give you a practical sense of what we went through at the University of the Free State. So Teddy, over to you.
Okay, thank you very much, Dr. Wahl. Throughout the cycles, cycle 2 being the Bluetooth car and so on, it was, I think for most students actually, the most interesting part was building the Bluetooth car, although at the same time, it was also the most sort of challenging part on their part. So I think these cycles were actually very necessary, especially heading up to the race day, because through cycle 3 and 4, they learned from simple things as the speed and how gears are linked to the speed of the vehicle, the motor and how it works and the different voltages of it, from braking the car to steering the car, which was all then shown when they were racing the vehicle on the 15th of May. And then obviously the most exciting part was when they were directly involved now, where all the teams were there. It was live streamed and they were watching, and there were different houses were rooting for them as they are racing their vehicles. They had all the necessary information from how much energy the eco vehicle consumes, from how steering it can be done, driving slower or faster, and so forth. So all the cycles actually prepared all the students doing that. They struggled a lot when it comes to the coding parts, but the engineering mediators obviously were able to assist them and see that everything was then sorted out. And then when it came to organizing from the beginning actually to the end of the race day, it started from the very start last year when we had to collect data from the different, all the 180 students who are involved in the thing. We had to get their addresses so that we can first send the first kits to them, and then after sending the first kits, also send the second kits. So what was involved was a lot of work, and we needed to be very precise, especially with the addresses. And since the students were studying from home, we had to deliver the kits to them. So that is a lot of time that was put into that. And then heading towards the race itself, we obviously had big plans for the race. And then due to COVID, we were obviously limited to the things that we can actually do when it came to that. So we had people that had VIPs that had to come and so forth. I'm just going to go through quickly what was directly involved, especially with the race day itself and planning for that. Obviously, there's a lot of people involved in collaboration between the different departments on campus to assist in doing that. This starts with the planning and how we want the race to look, who we want to be there, how we want to execute the whole thing. And then the most important one for us at that time was the marketing. So after having decided when the race is going to be, who's invited, we had to market for the race and make sure that people are there. Since the students are not allowed to come directly to come and watch the different houses, but then we had to go through all of so that they are able to have streams where they can still participate online and watch and support their teams. Since this race was hosted on campus, we needed to get permission from compliance teams at the University of the Free State to allow us to host this event following strictly the COVID-19 regulations. So that was involved. The base was just getting all the permissions to host the race and getting all the marketing out there. And then it came to the very small and detailed things, looking at things that we'll need during the day. Prepping the vehicles just for the last bits anyway. If we look at the vehicles in the pictures that Dr. Wahl and videos that he's shared with us, we see that the vehicles have been nicely designed. This is all designs that each team had decided amongst themselves that, okay, we're gonna go for this design, and then we're gonna implement that and stick it on the vehicles. So in prepping for the vehicles, we had to get that out of the way, where the teams had to design what they wanted to do. And then we had to get quotations for printing, getting permission to print, and at the end, having those designs stuck on the cars so that each team can be represented through their vehicles. And while still at the vehicles, there's a lot of other preparations that needed to be sorted out before the race day. For example, the vehicles were already assembled by the instrumentation division, so the students couldn't do that themselves. But they had previously watched videos on how to assemble the car. It's very detailed videos that tell them what goes where and how. So they had to watch those videos, and so that during the race day, if needs be, at their different pit stops, they will be able to sort of adjust what they need to adjust if something happens to the vehicle. So given that, then we had to get quotations to buy tools and different equipment that is needed for the vehicle itself during the race. And then the vehicle also, anything could have happened. So we had to arrange for things like spare tires, if it needed to be changed during the race, so that they can still be involved and not be stopped by a simple tire burst. Yes, so those are all the things that were involved with the car itself. And then it was matters now of safety when it came to the drivers and those that are around the pit stop. So we had to get quotations to buy items like helmets, and so that the students, well, for safety reasons, they had to wear helmets while they're driving. Since it's COVID-19 at the moment, they also had to get nets and sanitizers and gloves when it came to doing that. On campus then, there are different things that needed to be arranged for that day particularly. This starts from the ground where the race will be. We had to organize for bins to be there so that the places can be clean at the old, and also for disposing of like masks and so forth. And then after preparing the area, we had to work with different departments. Obviously, we have to make sure that there's enough bins, enough toilets at the area, enough sanitizing stations, and so forth. For communication, while we're on the ground, we needed to have safety marshals. Obviously, this is a race and those cars are moving at quite a speed. So still for safety, we had to go through organizing things such as ER24, so that if anything could happen, they were on the site and were able to assist when it came to that. We organized fire extinguishers through previous sponsors, and also radios for the communication on the ground from the different safety marshals that were assisting during the race, so that there's communication. If anything could happen at a particular place on the track, then would get communication to either the ER24 or a fire extinguisher that needed to be there. So we had to consider a lot of things, especially to get that out of the way, the safety part. And then obviously it goes without saying we have to inform the university on their side as well to be aware of such things. So like things like risk categories and stuff like that, documents that needed to be prepared beforehand so that they can be submitted to the different departments that deal with safety at the university. And then the track itself. In previous races that we had a lot of different sort of say races that we needed to do that we've done then. The different races, for example, endurance race, obstacle course, and stuff like that. So we had to relook at that and how we're going to set out the race, considering now that we want to show how to save energy efficiently using those eco vehicles. So after the cars were charged in the morning, they were all at the same amount of energy, and then the races were then set out so that we can establish if the vehicles used energy and how they used energy and so on. So the races that we've had in the past had to be slightly changed so that it can bring out the usage of energy and on the vehicles. So that was that part in arranging for the different races. The different races obviously had to have different categories and also different prices at the end, because it was a race after all. So the different prices, that would include then now the different trophies that were involved to be handed out, and then we also medals for the students to sort of show the winners and stuff like that. So those are all items that were then quoted for and bought to make the race successful. And then it came to streaming of the race. So since people were only doing this through, only the drivers and the immediate teams were in the race area, the rest could watch online, which was streamed on YouTube. So if you do want to visit that race, the full race, it's I think 1 hour, 15 minutes. If you want to view it, you can just type eco vehicle race and then it will show on YouTube. So that streaming then, we had to obviously get quotations for the people to do the drones, which were flying over the different cars and following them through to show the race on the streaming. There was a lot of screens involved for the viewing, internet, and other nitty-gritty things that were handled by the ICT department with the streaming and the platforms and where all the things would be streamed. So those are the items that were needed to be kept there in hand. And then to the people who are assisting, which are the safety marshals, the MCs. One of our MCs was the building coordinator of the project, so he was MCing the project, and also they had people that were a person interviewing the different drivers and the teams as they've been finishing the race and so forth. So that was organizing the microphones and everything for those people to be accommodated and so on. Right, and then since it was on a track on campus, we needed to be assisted by the traffic and the security on campus to control the traffic that was there. It was Saturday, so it's not a lot of cars moving at that point, but we also had to arrange for traffic to block out the roads on campus that we will be needing to do that. So there's that. And then obviously the areas at which those people would be using as sort of the headquarters where they would set up their equipment. So we had to get gazebos or shade where they would be able to sort of set up their systems and in an area where they'll be able to broadcast to all the students that were involved. So that's just some of the things that are involved in planning the things step by step. So what we did was we used a checklist of all the things that we want to do through that race, and then we'd go through each one as it's been confirmed. We'd tick it off so that we can reconfirm it again when it's closer to the race. That was basically it when it came to organizing the race and all of that. We obviously, after that, needed some people helping as well. So to wrap up everything after the race, packing up and so forth. So that's it's a lot of people helping. We had a lot of student volunteers that were assisting in that regard. Dr. Wahl, thank you.
Awesome. And I really, and the COFSE ACT team really did a sterling job in this. So I just want to share maybe 2 or 3 videos of some of the participating students that were during what they said.
Hi, so how was the race for you?
It was just great. It was great because the whole idea is to complete the race under 3 minutes. It's a smart lab, so you have to work smart.
So how did you work smart for you to be here under 3 minutes?
Just keep, you don't have to accelerate, just, keep, yeah, man, you get that I'm feeling?
I do get your drift. Thank you so much.
All right, so that is one of the videos that I just wanted to show you, just to give you a sense of, what the students said that were actually participating in the race. So maybe another one.
Driver number 7 is from Team Sweet Barista. And the question I have for you is, what challenge did you face during the race and how were you able to overcome it?
Okay, the challenge that I faced was the hoople. I didn't know about the obstacle that we're going to get there. But next, after that obstacle, it was fine.
Okay, thank you so much. And what can you say to the other teams that are coming after you? What can they look out for?
Just be aware of the obstacles.
Thank you so much, Sweet Barista. And over to team number 3. I do not see your car name. May I please know the name of your car? Oh, Team Karasman, your name is Tabiso. May I please just know from you, how did you find the race?
It was fun, except the guy kept on coming in front of me. So,
so are you blaming him for your mistakes?
No.
Okay, thank you so much. And what did you enjoy mostly about the first lap?
All of it.
All of it. Okay, thank you so much, and good luck to the next driver.
Okay, so that gives you a sense, maybe one last one, just about race day before we go on with the presentation. A bit of action on that day.
Anton, I am with car number 4 and I have Peter with me, and Peter will explain, because at the beginning of the race, he said their team is going to take the cups home. And I just want to say, how do you feel now after the problems that you've experienced?
Yeah, I think we might stand still a chance to take the cup, but ish.
How are you feeling now that you've been helped and you are with your team members?
It's a very good feeling, because if you get stuck in a position and you make an accident, everybody is coming to help you and you will not be alone.
Okay, thank you so much and good luck, and I hope to see you at the podium, because your confidence was very high and I still see that it's still high.
Okay, so that gives you just a sense of, the experience of the students during race day. Right, so I would like to end off this presentation really with just a pause on some of the pedagogical considerations that we brought into the program, and for those educators that are attending this session this afternoon, this might be of interest. We have sort of layered a number of pedagogical principles in compiling this whole project. The first focus that we had was on what we call high-impact educational practices, and so that's a well-familiar term in higher education studies. And we've selected specifically 2 high-impact educational practices. The first one is learning communities, and then the other one is collaborative assignments and projects. And learning communities is really about the integration of learning across different courses. So therefore, we deliberately chose an interdisciplinary approach. In other words, getting students together from different faculties and study courses to put them together in teams. Learning communities also revolve around big questions beyond the classroom. In this case, the big question about sustainable energy. How can we save the planet by going green in terms of energy? It's all about working closely together as a group and also with academics, and in this case also the industry of the eco-vehicles. And so we brought in engineering sciences and students working together on these projects. Learning communities allow students to explore a common topic together, and they put on lenses from different disciplines. So that was a very deliberate approach, creating a learning community around green energy, sustainable resources, and so on. Next, we also focused on collaborative assignments and projects. We know now from higher education literature that if you allow students to work together and to solve problems in the company of others, they learn. And that's really what we've tried to do through these different cycles. The 5 cycles, students had to work together to solve problems and in the company of peers. And then also to sharpening their own understanding by listening to the insights of diverse others. And hopefully what you've picked up in the videos and the photos that we've showed you is that we brought in, or there is a lot of diversity also in the teams in that regard. The next pedagogical principle that we deliberately upheld is what we call mediated learning experience. So the difference between mediated learning experience and a direct exposure between learning is the following. If you look at the illustration, you'll see that S stands for stimulus, O stands for the organism or the student, and the R stands for the response. So if there's a direct exposure of the student, the organism, to the stimulus, and that student has to respond directly to the environment and make sense in the environment, learning, we call that a direct exposure to learning. However, if you place a human mediator between the stimulus in the environment and the organism, and again between the organism and his or her response, you again place the human mediator. We talk about mediated learning. And so what years and years, probably 6-7 decades of research indicated to us is that it's much better to create a mediated learning experience than a direct exposure to learning. So the way in which the material was created and the use of the COFSI ACT team and engineering mediators were intentional to place a human between the stimulus, in other words, the learning material coming to the student, and help him to take in the information accurately and appropriately, help him or her to think through and apply the information accurately and appropriately, and then to respond to the information in the activities and the building of the different products and the vehicle and participating in the race day in a way that is accurate and appropriate. So when we brought in the senior undergraduate students in engineering sciences, we deliberately called them mediators. And that was intentional in the form of the mediators, engineering mediators, and also the retired engineer that coordinated the program, was to bring in a notion of mediated learning. So in that regard, we also then created a skills program on our learning management system that we deliberately train the coordinator and the engineering mediators to participate as effective mediators. So I am back on our learning management system. So this is actually the 6th skills program that we've created, and we required of all the engineering students that acted as mentors or tutors, as well as the retired engineer that coordinated the program, we required of them to went through the skills program on mediated learning. So in that way, I'm not going to go into detail, but it is structured in the same way than what the other material is structured with. It's on our learning management system. So it starts with the introduction to mediated learning. What is mediated learning? It starts with a scenario, and we've got different characters, and then a reflection on the scenario, then a different scenario, then again a reflection, information on mediated learning, and so on and so forth. So I can maybe just give you a sense of what the material is about. All right, so maybe let's start with a short tutorial just to explain the difference between direct exposure and mediated.
Meet George and Emily. We will use their stories to explore the differences between a direct learning experience and a mediated learning experience. George and Emily are both studying art history, and their lecturer has planned an outing to a local museum. They will write a short essay to reflect on the experience once they return to class. George walks through the different exhibitions and is particularly drawn to the work of Jackson Pollock, an American abstract artist. George much prefers Pollock's work to the painting created by Frenchman Claude Monet, an Impressionist artist. He goes home and writes an essay about the differences between abstract art and Impressionist art, and uses Pollock and Monet as examples. As Emily walks through the exhibitions, she is accompanied by Elizabeth, a very knowledgeable guide from the museum. Just like George, she comes to the Jackson Pollock exhibition. However, as they look at his work, Elizabeth encourages Emily to name other artists that were doing similar work to Jackson Pollock, and to think about why these artists are using this particular style. Elizabeth then encourages Emily to think about South African artists creating abstract art. Emily does some research, and when she gets home, she writes an essay about how South African artist Bill Ainsley used abstraction to instill a spirit of experimentation and freedom into the practice of some of South Africa's most important Black artists. George's experience was a direct learning experience. In this type of experience, the developing person or organism is directly exposed to the stimuli. George has to figure out on his own how to take in the information appropriately and accurately, how to process information, and how to respond correctly to the environment. A diagram of this experience would look something like this. Although learning that takes place through direct learning is vital, it is often incidental and insufficient to ensure optimal learning and development. Emily, on the other hand, experienced a mediated learning experience because a more experienced person, Elizabeth, the guide, positioned herself between Emily, the developing person, and the artwork in the museum, the stimuli. The human mediator helps the developing person to make connections and to think deeper. This experience would look something like this. The essay written by Emily was a lot more insightful and deeper reaching because she had the benefit of a human mediator guiding her through the exhibitions.
Okay, so that gives you a sense of just the material that they had to go through in order to get a good grasp of mediated learning. I'm not going to go into detail, but there are actually 12 parameters that are associated with mediated learning. Right, so I think then that concludes our presentation for today. I would like to then hear if there are any questions or any comments that we would be happy to answer. Okay, so I don't see if you have any questions. You can just type it out in the chat box rather, and we would be happy to respond to that. Okay, then I think I'm going to give over then to Teddy for some closing remarks from Teddy's side, and then I will, from my side, just wrap up the session. Thank you, Teddy. Over to you.
Thank you very much, Dr. Wahl, for the opportunity. Yes, indeed, this has been a very unique experience for myself and most of the students, indeed. And even after visiting the different high schools in Bloemfontein, introducing our project to them, they found it very interesting. And I know their young minds want to be involved, especially in this project. It's very important in this generation of ours to obviously maintain energy the best way we could. And I think this project has given a lot of insight to the students and everyone involved in how to do that. And thank you very much, Dr. Wahl.
Thank you very much, Teddy. And yeah, Teddy is really, just yet again, really one of the outstanding staff members at the University of the Free State, and they've got a very strong team at the Corsi Act office. We're very proud of them. I've indicated right at the beginning that part of what we envisaged with this program is to create a blueprint that we could roll out to other high schools and other tertiary institutions in South Africa. And in that regard, we have started with a process to package all of this together in order to be able to roll it out from 2022 to other educational institutions. We've also started a conversation with Rob Wilken and Chantay van der Berg from the Sasol Solar Car Challenge to just explore how we could more deliberately link this initiative with the Sasol Solar Car Challenge. So this is still in the exploratory phase, but hopefully there would be exciting prospects that could open up in future also in this regard. So I think from my side, thank you very much for attending the session, and we really hope that you will keep on making a huge impact in the lives of young people in our country. Thank you very much.
Thank you very much, Dr. Wahl and Teddy. If I can ask everybody to please make their way to the breakaway tab at the top, where our feedback session will start at 3:30. That is at the breakaway section at the top. Thank you very much.